Oh, hi everybody! Welcome to the Neo4j online meetup. So we've got, as you probably noticed, we've got a World Cup special for you today. So, my name's Mark. So I work on the developer relations team at Neo, and then I've got my colleague Jesus.
And I'm Jesus, also part of Neo team, part of Field.
So Jesus is going to be representing Spain, and
right.
I'll be representing England. Currently, we're both doing pretty similar.
We're doing all right.
So for those of you who haven't attended one of these before, we just do a little bit of housekeeping. So Jesus is watching the YouTube live chat. So if you have any questions that you'd like us to answer, or any queries that you'd like us to run, let us know on that chat. But we'll also be sharing with you the database, so you can always try them by yourself. We've got code in parts of the presentation, so if you want to be able to see that clearly, you'll want to set your resolution to 720p in the bottom right-hand side of the YouTube window. So you can just click on the little cog and select it there. And again, yeah, any questions? YouTube chat is the best place, and it will. And if you're watching this afterwards, you'll see them on there as well. So with that, I guess we'll get underway. So I'm just going to share my screen now, and then we can get into the World Cup graph. So let's do this. So hopefully you can see that now. Okay, so World Cup graph 2018. So this is just a list of some of the tools that we've used to build this. So there's a lot of different ones. So hopefully there's going to be something here that is interesting to you, no matter what particular bit of software engineering or data science that you're interested in. So we're going to do a bit of stuff. We've got a bit of stuff in Python. We're going to be using Neo4j's APOC library. We're going to be doing a bunch of stuff with Cypher. We're going to use Beautiful Soup, the Python library, to get the data. We're going to deploy this into the Neo4j cloud, which is a Neo4j product that's currently in the early access program. We're going to use GraphQL. We'll be using AWS Lambda. We'll be using the Grand Stack, which is a tool for connecting GraphQL and Neo4j together. And then we kind of got a special edition that we thought we'd add in after playing around with it yesterday and today, which is Neo4j Bloom, which is a visualization and exploratory tool. So we're going to cover all that. This is the structure of how we're going to do it. So we're going to start off with just explaining this World Cup graph. We'll go through the model a bit, so you have an idea of what is this data set, what can I actually do. And then we're going to have a look at how to explore it with each of the three options. So we'll start with just doing Cypher directly. So we'll go Neo4j browser, and we'll do some stuff there. Then we'll go GraphQL, and finally we'll have a look at what we can do with Neo4j Blue. Okay, right. So the World Cup graph. Step one, I'm assuming most people know what the World Cup is. It would be surprising if you were at this meetup if you didn't, but just in case, here's some pictures from the World Cup. So obviously the greatest of all time, claim there by Cristiano Ronaldo on the left, and then some various images. And obviously, as an England fan, we're currently doing all right. So I've got to get obligatory picture of Harry Kane. I think this one is actually when Spain just conceded a goal. So Jesus is not happy.
Yeah, they're trying to understand what happened actually. Yeah, but it's still
I thought it was for you. I thought it was for you. That's the goal. And then obviously
not me too,
at the top, not a great night for Germany yesterday. So we've got a graph model representing the data for this competition. So it's a football competition, and this is what it looks like. This is using a tool called Arrows. In case you've not seen that before, we'll probably share a link for that a bit later on in the session. And you can see. So the way to understand this is if we begin in the center of the graph, it all centers around the World Cup tournament. So for example, we have a node representing the World Cup. And so, for example, there will be one node for the 2018 World Cup in Russia. There might be another node representing the Brazil World Cup 4 years ago. Each country, so if we come over to the left, you can see there's a node called Squad. And this is a set of players who represent a country in a World Cup. So you would be named into the World Cup squad. And at the moment, you have to have 23 players in that squad. And you can see that there's a connection from the country to the squad on the left-hand side. So the country names a squad for a World Cup. And then players can be in that squad. So, for example, there are 23 players representing Spain, 23 players representing Germany, 23 players representing England, and so on. If we come down to the middle of it, we've got the World Cup can contain matches. So each match would have a connection to the World Cup that it was played in. And then there would be a stadium that had the match. And a player can make an appearance in a match. And on this appearance is a bit of a bare node at the moment. It just literally sits there, and we connect goals to it. One thing we could do as an extension of this is actually store more information about the players' performance in the match. So maybe we could keep track of the assists they did, the cards they received, the shots they had, and so on. But this is the model that we're going to be working with. If you don't want to hear, if you just want to get your hands on this data and give it a try yourself, this is where the database is. So Jesus is going to copy this link into the chat as well, so you can grab this. And this is a database running on the Neo4j cloud. And if you log in with World Cup as the credentials, then you'll be able to get to that. And if you want, so you can either just play around with it on your own and just see what's in there, or we've made a Neo4j browser guide. So if you type in :play World Cup -2018 queries, that's got a bunch of pre-made queries for you. And we'll come back to that later on in the presentation. So what is in this database for those of you who haven't opened it up yet? Let's have a look. So we've got in all the matches, all the squads, all the appearances of players in those matches, and the goals scored, starting from the 1930 World Cup all the way up to the 2018 World Cup. And this, so we've got the historic data, and we've also are updating it every 5 minutes. So we've got a Lambda job running on AWS Lambda that's polling a rogue API that I found on my network traffic while on the FIFA website, and this is pulling in the latest updates of the matches.
We probably have the goal that Colombia scored only 15 minutes ago, right?
Yeah. So so if you want to test this graph, check what the score of the Senegal-Colombia matches, and it should have the goal that's happened there. So it's reasonably up to date. So it should be up to date within the last 5 minutes. So how do we get the data? So just a brief explanation of this. If you want to grab this data, it's sitting in this repository. If you search for github.com mneedham Neo4j World Cup, you can see all the scripts that we've got in there. And it's actually an extension of a data set that we built 4 years ago. So you'll see there's a bunch of Ruby scripts and a bunch of Python scripts. And maybe I'll show you some of them a bit later on. But we're basically just downloading the pages and finding the appropriate metadata from them. And this is what the workflow looks like for the historic data. So I thought I'd get one bad match for England and one bad match for Spain, because I mostly wanted to put that Spain match in, but I wanted Jesus to still attend. So
you picked the best one, definitely.
So I've got Spain's amazing defense of the World Cup. 4 years ago.
It seems to be a trend. I mean, you see in Germany, it's a rule lately.
Yeah,
I mean,
you've got to go out.
The last 5 years, I believe 4 world champions just go out in the first round of the next one.
Yeah, so it's not going well. So if you win it, it's not going to go well for you in 4 years' time.
Guaranteed.
So we've downloaded these matches locally, and then we use a Python library called Beautiful Soup, and we can basically just do CSS selection across that data. We generate some CSV files, and then we use the load CSV clause, and we load that into a Neo4j cloud instance. If you want to play with this locally, you can obviously just run this on a local Neo4j instance. You don't need to use the Neo4j cloud, but we thought this would be a nice thing to play with. So this is currently in an early access program, and you can register to be on that, and I'll show you a link for that later on. This is what the raw data looks like. So we get, you can see we just get some CSV files. On the left, we've got the World Cups. You can see we get a year, we get a name for the World Cup, and it indicates who the host is. If we come up to the top right-hand side, these are the matches. And then down here, we've got different events that can happen in the match. And if I just zoom out of the presentation temporarily, I'll just open it up so you can see what we've got. So you can, on this page here, hopefully you can see that if I zoom in a bit. We've got some CSV files, a few CSV files. So for example, I could open up this one here. So this is the matches CSV file. So you can see we've got the Russia World Cup here. We've got the Brazil World Cup, and it indicates who the host is over there. There's only a few columns in this one. We could then go in to the matches one. And for example, we could go and do some searching here. Say, hey, find me England. So there's some matches from the 1966 World Cup. And there's more. Maybe we could say find the Netherlands. There's a match between the Netherlands and Brazil. I think that's, I was going to say it's 98, but it's actually 94. So you get, we got some IDs representing the teams in the match. We've got the score in here. We've got the date. So we're able to use Neo4j 3.4's new date time functionality. We've got the stadium in there as well. We've got the round that it happened in. And this is quite interesting because they're not necessarily consistent across the tournaments. Sometimes you'll see rounds done in a bit of a different way. And then we've got the World Cup that had happened in the host country. And then this last one is for some extra information if the match went into extra time. And then alongside that, there are a bunch of Cypher scripts, and we'll come back and look at those in just a second. Okay, so we've got those CSV files. And if we want to import the data, we're running a command called load CSV. So this is a tool that comes baked in with Neo4j, and it allows you to process CSV files. And the way that it works is that we basically have a piece of code iterating over every line in a CSV file, and then we do some sort of what we call a Cypher transformation on every line. And a Cypher transformation will take that raw data in the CSV file and do something that creates some data in the database. And we can use different clauses. The one that I tend to use the most in these type of import scripts is one called merge. And the way this works is it will create something as long as it doesn't already exist. So if we just have a look at this example here, I'm saying I want to merge a match. So I want to create a node with the label match, and I want it to have a unique ID based on whatever the ID property was in my CSV file. And then I want to go and set a few properties. I'm going to set the home score, the away score, the attendance, the date, description, and then the match number. This is not the whole script, but you see we also we populate the home team, we indicate the away team, and then we're also capturing which year the match happened in. And if we so that was just to show you a zoomed in one, we could go out here and you can have a look at all of those on the GitHub page directly. So you can see, for example, here, I simplified that top line, but if you want to run it yourself, you can actually pull the CSV files straight from GitHub. So you don't actually need to download anything. You can just run this script exactly as it is, and it will create you the database locally. And you can see we also add in a few extra labels in here. I don't think these get set perfectly, but they do reasonably well. And so this is if we detect that there was a match that went to extra time or penalties, we want to put an extra label on for that. And then the only other piece that we've got different than what I zoomed in on is that the way the data is displayed on the FIFA website is a bit weird for the 2002 World Cup. It's not quite correct because there were actually 2 hosts, and on there they only indicate that Korea hosts it, because I think it was called they call it the FIFA World Cup Korea, and so we just did some kind of just a bit of pre-processing before we load it in. So that's how we load the matches in, and then we do a similar thing. For example, this is for the squads. So this is a little bit simpler. So we're saying I want to load from the squad CSV file. I want to make, and then I'm finding a squad node that will exist for that particular year, for that World Cup, and then we're attaching the player to it. So this is where we create the player, and we just have to do a little bit of work, a little bit of pre-processing down here on lines 16 to 20, because some of the players don't have a date of birth, so they don't have a date of birth for every single player. And we don't want to go, we'll just not bother putting in a date of birth. So we'll just leave that property empty if there is no date of birth. And if you call this date time function with an empty value, it throws an exception. So we just need to handle that ourselves. Okay, and then there are a few other CSV loading scripts as well. So this is just showing you 2 of them. Okay, so what we're going to do now is we're going to actually run some queries on this so you can see the types of things that we can do. So here's a quick reminder of the details, and Jesus has already pasted those onto there. So I've got it logged in already on my browser, my next tab across. And so what we can do is we can have a quick look on the left-hand side of the, so on my first sub-menu, and you can see what have we got in here. So you can see we've got the graph that we suggested initially. So we've got appearance, we've got country, we've got match, we've got squad, we've got the away team, home team, we've got World Cups in here. And maybe we could just start with a really simple query. So we might say, I want a match on the World Cup where the year is 2010, say, and I want to return it.
It's a good choice of year.
So yeah, I've got to keep my code protector happy. So you say, okay, I've got the 2010 World Cup, and we can click it, and there's not really that much interesting there. So we just got, it's the 2010 World Cup. But maybe we say, okay, let's see whether we can find the host. So who was it hosted by? So we could go hosted by, and we can pick up a country over here. And maybe we can make this whole thing be a path. So what I've done now, for those of you not familiar with Cypher, we've got, this is matching what we call a node. So we're finding a node with the World Cup label and a property year matching 2010. And then once we've got that node, then we follow a hosted by relationship, and we pick up another node on the other side called country. So it's a node relationship node. And then we're just saying the whole thing is going to be in a variable called path. Yeah. And if we run that, probably not too surprising. So we just said, find me the 2010 World Cup, tell me who hosted it. We could then do another query. So we could say, I'm going to continue my query, and I want to find, for that World Cup, can you find me the World Cup final? So we go here, we say there's a match here, and I want the round to be the World Cup final. And we'll just capture that as a path as well. So say this is the match path. Right? And we'll return both those paths back again. Okay, so there we go. So we've got 2010 World Cup, and we know there was a match, and it was the Netherlands versus Spain. What we might try to do next is go, so we can see that Netherlands and Spain are in there, but we might want to actually capture the nodes for those teams. So what we can do now is we can say, let's get the, we'll just call this the teams path. You don't necessarily need to name all your paths. You could just literally write the path. So maybe I'll do that for this one. So we can say from that World Cup, from that match, sorry, this is the final, tell me who played in the match. So if you, so we've got some different relationships in here. So some of them are a bit duplicated, which kind of makes some queries more interesting. So we've got, so FIFA kind of represents everything with a home team and an away team. But I also realized it was quite nice to be able to just say, show me the teams with one query. And so what we can do here is we'll just do a star. So now we get the FIFA World Cup in 2010, hosted by South Africa. And in the final, we've got this match here. So maybe we'll just change the match to show the match ID. There we go. So in the match ID, we had Spain and we had the Netherlands. And on the played-in relationship, we actually captured the score. So in here, you can see the Netherlands played in a match, score 0, and obviously for Jesus, score 1. So obviously, we want to figure out who scored in that match. So if you remember, we can we've got an appearance node, so we can go and add that on. So we can say, hey, find me in this match who made an appearance, and in that appearance, who scored a goal. So we can capture that as well. So we get the goal. Hopefully that'll go in. So there we go. We've got a goal down here. So at the moment, it's not attached to any of the other things. So we know there was a goal. It was in the 116th minute. So it's a pretty late goal. So hopefully, like, if you know who the answer of who scored this goal is, put it in the chat and see whether you can tell me the answer before I figure it out. So I'm going to just capture this as appearance, and
the appearance represents every occurrence of a player playing a game, right?
Yeah.
Is that what it? Yeah.
So we got. Oh no, I need to try and remember what. How do we? So we've got from the player. They can either start the match or they can be a substitute. And so we've got the answer over here. So hopefully you've got it. Yeah, you've got it over there.
Faster than anyone else, Mark. No one has.
So there we go. Yeah. Cypher, Andres Iniesta played in the match, scored the goal, and what was the match? It was the World Cup final. So this is how you would go. Like, this is building up. This is how you build up queries in Neo4j, and it's quite like as long as you like. If I was doing this, what I would probably do is I'd keep that model open on one side of my screen. So that I can remember in case you forget, like, how are these things connected again? Keep that open on one side. And we've actually got a blog post where we wrote about this. So if you go to the, I'll just show you. If you go medium.com/Neo4j, we wrote a blog post about this World Cup graph, and so you can read all the explanation of the model in here. So for example, here's the model, and so what you could do is if we were working on this, we could stick the model on our left-hand side. We could have our browser on the right-hand side, and then we can easily just check. Like, for example, if we wanted to now add in the stadium, let's say I was like, how does the match connect to the stadium? Well, actually, the match is played in the stadium, so I might choose to add that in here. So okay, let's add in played in. I can't remember if it's played in stadium or just maybe the diagram is a bit wrong. But we could add in, yes, I think it's just played in. Let's check. So hopefully we can just get the played in stadium. So where's the stadium? Do we see it? Or maybe not. It should be on there somewhere.
Returning it?
Oh, maybe
probably not in the return clause. Oh no,
return
star.
It's strange. It's not. Maybe it's not connected to something. I don't know. It should, in theory, it should show there, because if we didn't actually match that relationship.
Well, played in is just the country apparently. It's not the stadium. It's just.
So maybe we don't have the stadiums in there, but in theory, we should be able to find our stadium as well. So there we go. That's what I get for trying to be too clever.
Well, you can probably try to expand all the if you double.
Oh yeah, so that's a good point. So we could actually do a bit of manual exploration. So what it does now, so I'm just going to make this full screen again. So you can actually double click on that, and it will pull out. Actually, in this case, it's all the appearances of anybody. And there we go. Actually, we have got the stadium. I just must have typed it wrong. So it's played in stadium is the relationship type, and it was in the Soccer City Stadium, which is I don't think we then have anything connecting to that. But
probably you were using the direction of the relationship.
Yeah, that's probably right. Yeah, so we probably just had the relationship wrong. And then we could see. So you could then go over to that Soccer City Stadium and see what other matches were in that stadium, and you can see it pulls out a few other ones as well. I'm not sure what match that is. Maybe we can see. There's a Denmark-Holland match, and then it had a few other ones as well. So what I'm going to do now is, so I'm just going to close this down, and I'll just show you what you can do with the guide that we've created. So if you want to follow along, so we've got play World Cup 2018 queries. If you want to import the data as well, you can do play World Cup 2018, and then there's a whole load of queries that actually create the schema and import the data alongside it. But we've already got the data at the moment, so there's no need to do that. Nice thing here, we can check the schema. So if we want to check like what was actually in there, we would already learn here. Actually, it's played in stadium. So maybe I should have checked that before I did it. And we can actually color all this in, so we can see what's going on. So maybe we can just make all these. So that's match. So we can make match, and then we'll just put the name. And you can kind of see the whole schema that we had on the arrows diagram at the beginning. We've now got it in here too. And so we've written a guide that will allow you to go and explore it, and gives you like some simple queries to start with. So for example, we could find the hosts of the World Cup. And so this one's just another version of that. Has anyone hosted the World Cup more than one time? We could write that query. So you can see this is just a variation on the first one. So there's 4 teams that have hosted it more than once. Fun fact is that actually Germany have also hosted it more than once, but the first time they hosted it as West Germany, and so that obviously shows up as a different relationship. And so perhaps a variation on this model would be actually, do we want to say that this is actually a common thing that Jesus and I noticed, is that, for example, Germany kind of used to be West Germany, and Yugoslavia appear in some.
Have a geopolitical component there.
Yeah, so maybe there should be something in there as well, saying, okay, well, actually now this country is composed of these other countries. So there could be something like that in the model. We can find out if the hosts have ever won the World Cup. So we could run that query. So this is where the hosts have won it. So it's been a while. So what we're doing here is just checking when we find the host, and then we check when they played in the final, and then we find the opposition in the final, and then we check, did the hosts have a bigger score than the opposition, or did they win? That should say, so this should say penalties, actually. I've got a bit of a typo in there. Although it doesn't matter on this occasion, because I don't think we've had a penalty shootout between the host and someone else in the World Cup. We obviously have had penalty shootouts in the World Cup, but we haven't had one where the hosts were participating. And so you can see here, these are the scores where the host won the match. We can obviously find the finalists. We can do the top scorer across all World Cups. So this is a very common one that you'll hear mentioned by statisticians. Not so much in this World Cup, I haven't heard it, but certainly in the last one, it was really interesting because Miroslav Klose broke the record.
Exactly. The thing is, he's played like 4 World Cups, which is...
Yeah, whereas the next 3 people have only done... Well, so Ronaldo did 3, Müller did only 2, and Fontaine just did 1. So he's probably... I think he's got the best in one
look
single...
at the ratio.
Yeah, we should do...
Goals per game. Or...
Yeah, so we could do that. We could say...
you can count the number of appearances, actually.
So we could do... So we could say... We could update this a bit, say goals, and then goals divided by size of... I have to times that. This is like goals per tournament. So presumably this will now put just Fontaine at the top. There we go. Goals per tournament. The order changes quite significantly. So we've got some people on a 6. I'm guessing most of these people only played in 1, but we can check. So we can still return those competitions. So there's actually one. So Müller's got probably the best of the people who have done more than one. So we could even filter that if we wanted to. We could change that and say where the size of the competitions is greater than 1. So these are people who scored the highest average goal scorers who played in more than one tournament. And so you see now we've got the Brazilian Ronaldo is back in second spot again. So and actually closer is not too bad there. He's in the top 10 also. So if we just go on to next one, so we can. What have I done? I might have closed it actually. Let's see. So we can actually go back through our history and find our play command again. So there it is. And I'll just click through to get us back. So we could check who of those top World Cup scorers has actually got a chance to add to that. So who's in the squad now? So Thomas Müller was actually in first place, but he's obviously not got any more matches to go. Ronaldo still in the tournament. Suarez still in there. Rodriguez still there. Messi still there.
We don't know.
Higuain,
most likely.
Higuain still there, but based on performance 2 days ago,
not sure that's going to
very
change.
Unlikely to add any goals to that. We can also find out which players have been named in squads across multiple World Cups. So this doesn't necessarily mean they play, but it does mean that they were named in the squad. So we've got Marquez in the top is the one who was added this year. We then have Buffon in the previous one. And we've got Mateus and Carvajal from like the last time that England were any good back in 1966. And then we've obviously got Maradona closer, and then Casillas in there for the top one for Spain. Goal scoring substitutes. This is quite a fun one, but so if you have to go back quite a number of years. It's almost 30 years, I guess, to remember Roger Miller. I do remember seeing videos of him. Always, nearly all his goals, I think, came as a substitute. He was always on the bench.
That's for Nigeria, right?
Cameroon,
okay,
yeah.
Right.
So he's always on for like the last 20 minutes. 2 goals, won the game. So, but there aren't many substitutes scoring in the current World Cup. And so we'll finish off our cipher tour by looking at top scorer by country. And so the top one's obviously going to be the ones who were at the top of that, the top scorers overall. But we can also see like England's top scorer. So for example, Gary Lineker's in there with 10. So Harry Kane will be trying to see if he can close that gap. Okay, and these are just a few of the things that you can do. So if you have anything else you'd like us to try, feel free to ask us in the chat, and we'll see if we can answer your questions. But hopefully you can see there's lots of different things that we can answer. This is just some that we came up with. Okay, so that's a bit of Cypher. But what happens if you want to query this data set and you're not very comfortable with Cypher? So we have another way. We have GraphQL. So this is something called the Grand Stack. So this is being sort of led by my colleague, our colleague even, Will Lyon. And so this is a tool chain that he's been working on combining 4 technologies. So you've got GraphQL. So this is you can consider it kind of like a REST API equivalent. It's like a query language for your API is probably the best way of thinking of it. And I'll explain it in a little more detail in a minute. It also includes the React front-end tool, the Apollo GraphQL client, and Neo4j on the back end. And so we've tried to make it really nice to use all of these components together. And in the middle, we've got the Grand Stack logo. So what is GraphQL, if you've never come across it until this point? So this is how it's described on the GraphQL website. So a query language for your API and a server-side runtime for executing queries by using a type system you define for your data. What does that mean? So first bit, a query language for your API. So there's quite a nice blog post on Medium. REST APIs are rest in peace APIs, long live GraphQL. And so the idea is that for some use of REST APIs, probably more like HTTP APIs serving JSON data, GraphQL works really well because we can get back exactly the data that we want. We don't have to call these APIs where we get loads of data that we're not interested in, and we have to call lots of different endpoints to pull together all the data that we want to show on our page. You've got a server-side runtime for executing queries against it. So you can actually use this tool called Graphical, and we can actually run live queries against it rather than having to go and run a query in our application and get the results back and see, okay, did that actually work? We can actually just go and run live queries against it in a very similar way that we did against the Neo4j browser. We can do the same thing here. And finally, it's all based around a type system. And usually the way that you would do this would be you would define a type system up front. So for example, here we've got a very simple type system with a character and a planet and a species. And you define what fields exist on that schema. So you can see here we've got character, it has a name, which is a string. A character can have some friends, which are other characters, so that's a little bit self-referential. We can have a home world, that's a planet, and that takes us over to the middle type. which has a string, a name, and a climate. And a character can be part of a species, which then takes us over to the left-hand side where we've got a potential lifespan, and then we can come back again to the planet for the species origin. Normally, when you're building GraphQL APIs, you go from your GraphQL endpoint to what we call a resolver, and then finally over to your data backend, so be that Neo4j or be that something else. And you often have to write manual mapping code to go from your GraphQL API to whatever your backend data source is. And that is some seriously boring code to write. It's not particularly fun times if you have to do that. And so we built a tool called Neo4j GraphQL.js. This is an npm library that you can use. And we've got a blog post about this one as well, so we can probably share that link in the chat. But bit.ly/World Cup-GraphQL if you want to read about that. And so we actually built the API after we already had that World Cup graph. And so this post just goes through in a bit more detail how we did it. And we actually used a tool that Will created called the GrandStack Starter Kit, which you can find. So if you go GrandStack GitHub, you can find that on there. And this is a really nice project that kind of has everything set up for you. And to get an API, all you've got to do is change 2 files. So the first file is the schema file. And so this is just a subset of the schema that we created. If you want to see the full schema, we've got that on these bit.ly links. So you can see a bit of a cut down one at bit.ly/World Cup-GraphQL-schema, or the full thing, World Cup-GraphQL-full-schema. But just to go through it, for our data set, wherever we had a label, we're going to have a type. So for example, type match, type World Cup, type country. And you can see, we can say on a match, I've got an ID, I've got a description, I've got a home score and away score. And then where you have a relationship, so for example, we want to pull in the home team. So for just string values or integer values, we just define them as they are. If we want to pull in some data from a different part of the graph, so another node, we need to specify what relationship does that refer to. So for home team, we want to look up, and we use this @relation directive. We say there's going to be a name, the name of the relationship is home team, and it's a relationship going out, and that will go and get me the home team. And I can do the same thing to get the away team. And that will get me down to country, which is down here. When I'm at country, I can pull in an ID, a code, a name, or I could go and get their hosted World Cups. And the way that the hosted World Cups works is it goes and follows the relationship hosted by coming in to the country. And so we go and get the hosted World Cups, which might take us up here. And the World Cup's not that on this particular one. We've narrowed it down, so you can just get the year and the name, or you can go back to the host. And then to query the whole thing, we need to then define a query type down as we've got on the bottom of the screen, where we say, like, what's the entry point for people querying this graph? So once we've defined that schema, so we define the schema, we can then specify our credentials for our Neo4j. So you just have to set 3 things. So we put in the bulk URI for our database. So in this case, it's C27D992B.database.neo4j.io.
I have a question on GraphQL. So that comes from Benny, and he's asking if the starter pack comes with combined with Express, or does it just utilize Node?
I think it's just utilizing Node, but I'm not really the expert in the GrandStack starter kit. I literally was just trying to see what's the minimum I could do to get an API up and running. But we can we'll share you the link for the GrandStack starter kit, and then you can see whether or not it fits in nicely with the rest of the tools that you use. But literally, yeah. So to get this up and running, we just had to do this, and then we're using a tool called Now, which allows you to deploy lots of different build systems, I suppose. And then in this case, we can deploy a Node.js application. And so you just go, literally, you have to install this tool. You go to your directory where you've got your code, and you just type Now, and it will deploy it. It will ask you, do you really want to deploy this? And it goes and deploys it, and it gives you a URI where it's hosted. Sorry, Will, yeah.
From Will.
I'll let you. Will's say. So Will's explaining what the.
Yeah, he's explaining that it uses Polo server, which uses Express under the hood. So
okay, so it does
Ben's question.
So we are using Express in answer to that question. And so what we do here, so you can see we get a link: World Cup-GrandStack-RASNFD QBRB, which is a bit difficult to remember. So we use we actually created an alias. So if you want to try this out yourself, World Cup-2018.now.sh. So I'm going to go there myself, and we'll have a quick look at what we can do on this data set. As actually, I've cheated a bit and got it over here. So this is what we get. You get this nice area where we can play around. So what I've done here is I've got a query, and I'm saying I'm going to pass in a parameter. I'll make this a bit bigger, actually. So we pass in a parameter called match ID. And then down here, we can pass in the variable. So I've gone and looked up one of the matches, and I've just got it. And so I say, find me the matches. And then in here, you get like an autocomplete. So I can say, hey, get me that ID. And obviously, that's going to return the same ID as before. And I can say, what date did this match happen on? And, well, what is the match? So I could either get the description, I could get the round of the match. So first stage, group F. You probably can figure out where this is going if you've been watching. We could load in the home team. So we can get the home team, we can get the away team. And each time, this is kind of taking us down like a bit of a tree. And so no prizes for getting the troublemaking that's being done by an Englishman over here. So I could load in that home team. So we've got England in here, and Korea in there, and we could say, show me the hosted World Cups by Korea. And I just want to know what year did they host the World Cup. And so I could do that, and this is all in one cipher query. So I mean, I don't know why. There's not necessarily a reason why you would do this query, but maybe I want to find what World Cups Germany hosted as well, and it will come back with 2006. I'll take that out of the query for the moment. So if we wanted to, let's just remove the hosted. What we can also do is we could get the score of the match. Probably not great reading. Obviously, if you support Germany, and it tells us that Korea won 2-0. We could get the scorers. So if we type in goals, and we just do some tabbing in there, we can get the scorer. So we might want to grab the name of the scorer. We can get the type of goal they scored. So this will be the type of goal is own goal, goal, or penalty. And then we can get the time of the goal. And so if we look at that, we see both the goals were scored in injury time at the end. We could also find out all the players who played in the match. So if we do appearances, we can get the player. We get the name of the player. We can indicate whether they started the match or appeared as a substitute. So these are a load of the players who started. We've got some substitutes in there. And obviously, when you get to the player, you could choose to, so I'll just prettify that. It's a bit easier to read. You could also then find what squads have they represented, what squads have they been in. And for example, we could find out what country they were representing. Obviously here it's going to be Korea Republic, and we can find out what year that was in. So we can see here, Lee Yong, who was starting the match yesterday, represented Korea in the 2018 World Cup, which kind of you would expect given he played yesterday, and also the 2014 one, whereas Yoon Young-sun, this was his first World Cup. If we go down to some of the German players, maybe I search for one of them. So we search for Müller. So Thomas Müller, on the other hand, so he started as he was a substitute, and he's played in 3 World Cups. So he actually played in the 2010, 2014, 2018, whereas the goalkeeper Mark Andre ter Stegen started as a substitute and has only played in this one. Gomez is an interesting one. So I guess played 2010, skipped 2014, back in 2018. So that's actually another query that we could do, maybe a bit more interesting, is actually go and connect those squads together. So can you find out like which players played in consecutive ones? Was there ever anyone? Like, what's the biggest gap that somebody had in a squad? And when we're doing GraphQL queries, most of the time we're kind of traversing down a hierarchy. If we want to do anything more clever, we'll likely want to do some custom cipher for that. So let me just show you some of the custom cipher that we introduced in here. So let me just go show you the full schema. So one nice thing that we can do, so I'll just show you from a query, is if we search for a player, so if we decided, okay, I'm going to search for players instead. So I'll just delete this match in here. So I can say I want to find a player, and I want to find their name, Cristiano Ronaldo. So say we're looking for Ronaldo. Oh, got to get this one matching. We could say, can you show me how many goals did Ronaldo score? And it'll tell me he's got 7 goals. And I can also search for a particular tournament. So 2018, he got 4 goals, because of 2014 as well. Only 1 goal. Now, how do we do that? So we've actually made a all goals thing in here. So there you go. So you see here, we've got an all goals attribute on players. And what it does, what you can actually do is you can write in some custom ciphers. So what we're saying here, so this represents the node that we're on. to say from this node, go and find all the matches that this player played, find where they scored a goal, check it was in a match, and make sure it was a goal and a penalty. I suppose we could also add something that found own goals, and then what we're doing is we're just saying return count star. So that goes and finds all the goals that were scored by a player across all the World Cups. And so we could do the same thing from Miroslav Klose, for example. So he's got 16 goals, only 2 at the 2014 World Cup apparently, but 4 at the previous one. And we could also go and find, so what else can we get? We could get the squads that these players have been named in. So we could go find the squads, find the country that they were representing, obviously always Germany, and we could say what year was it in. So Klose 2002, 6, 10, 14. And we could find, we could actually go and find their appearances as well. So we could say, okay, show me the matches that they played in. Ooh. So that's what you get if you execute an invalid query. But there we go. Those are all the matches where Klose had some part in the match. And if we wanted to know, well, what World Cup was that in, we could find that as well, I think. So if we go to the match, we could say, can you tell me what World Cup it was and what year that was in? And then we get back down here, we see, okay, played Germany, Sweden 2006, Germany, Spain 2010, Germany, Serbia 2010, and then a few other ones as well. And so this is quite nice. So we can, I'm going to leave it there. But if you want to play around with some other queries on here, these are the places where you can write queries starting from. So you can start from matches, you can start from World Cups, you can start from countries, or as we've seen already, you can start from players, and you can kind of navigate from there. So I'm going to come back into our slides again. I'll just skip forward to where we are. So I want to query the data. I don't want to do GraphQL. I don't know GraphQL. So how do we query it?
Can I still explore the graph?
And the answer, of course, yes, you can. So actually, I'm going to hand over to Jesus.
Okay,
Jesus is going to drive us through this next part.
Cool. Okay, so let me go to.
So there's a few slides actually before we get to there. So we'll just explain what we're going to do. So we've got where do we go? So we'll just get back in which browser was we're in.
That's it.
This one? Yeah, so we're going to show you a tool called Neo4j Bloom, and this is going to be released in the next few weeks. So this is a tool for visually exploring a data set. So if you don't want to write any Cypher, any GraphQL, this is quite a nice tool for doing that. And there's a blog post about it, so I'll show you the link for that in a second. And this is just showing you some of the things that you can do. So the idea is that you can do visual exploration, and it will give you back a graph in a visual way, and you can then choose to explore that in further. So we're going to take a look at this. So I'll just escape from here. And so Neo4j Bloom. So this is not a release thing yet, but we've got it set up locally, and you can see on this screen here, we've got it pointing at that World Cup data set. And I'll just put it into the Bloom terminal. So maybe we can just quickly explain how this thing works.
So what we see is what Bloom calls a perspective, right? So we have well, in a way similar to what we had in the browser, we have a representation of the different types of entities, basically correspond to the different labels. So we're already familiar with the different types of nodes that Mark has been querying and exploring. So we have countries, we have squads, we have stadiums, players, etc. So what Bloom offers us is a way of exploring this graph using not necessarily a structured language like Cypher, but expressions.
I realized that we've made a bit of a mistake in how we're sharing the screen. So we actually need to see if I can figure out how to do it. So we want to just share. We'll just share our entire screen so that we can hopefully now. Sorry, should be able to now. People should be able to see what we're seeing.
Okay. Right.
Yeah. Sorry. So yeah. So this is what. Sorry, that was my bad setup. So this is what Jesus has just been describing. This is the Bloom UI.
Okay. So and yeah. So we're saying one of the things we can do with Bloom is write something that's close to natural language, and that will be interpreted as we type based on the entities and relationships and properties that are in the graph, and let's try it, right? So what's
yeah? So maybe we can just start with something simple. So we could say, see, try what it's telling us.
So we know that there's a type of entity called World Cup. So if we just type World Cup, we see that Bloom is detecting immediately that matches the name, one of the labels. So if we accept that as one of the interpretations that we want, we see Bloom returning all the nodes representing World Cups, right? Another thing.
And so we could then go. You can kind of navigate around it. So you could, for example, we could go and double click on one of them and
so
see, like,
take,
if we've forgotten. You can't do 2010 again. That's cheating.
No, that's true. I was trying to find 2018. Now here we go. So we double click on a node and we see the properties that we have for it. I mean, in the case of a World Cup, we only have the name and the year, but we can look at the relationships that come out of it. And we saw that we had connections of type for World Cup that connected to squads that played in that particular championship. Can't remember what it contains match linked to, but it contains, well, yes, a link to all the games, and then there's a relationship to the host country, right? So we can, after selecting it here, we can pick a relationship and ask Bloom to reveal it, and it will expand the graph to include this host country, right?
Yeah, so you can see now we've got that yellow node representing. So you remember yellow is the country.
It's the country, correct, right? So, and yeah, I guess we can double click here and we see the information about the country. But we could do it that in a general way. So, and say, well, I want to see all the host countries for the different World Cups. So I can say I want World Cups hosted by, and I probably have to use capitalization, right?
No, I think it's look. I just pick it up.
Okay, right. So that's, and it's hosted by a country, right? I'm so used to typro.
Just a country.
That's the country, right?
Yeah.
And we see that it's mapped to the right expression. So if we expand this, now we find all the host countries for the different World Cups, right? We can zoom in or out from there. What else? So we can find for the different World Cups, we can find the matches in the final one. I mean, basically, it's we want to see all the finals for each of the World Cups, right? And we saw that a final is actually a match with round property with value final. So if we do something like that, we will get for, let's leave Bloom to lay it out a bit. But there are some interesting insights from these, kind of bird's eye view of the graph. Because if we just follow the colors, we see that the yellow nodes are the countries. So the first thing that I see here is that there's a probably highly connected node here in the center. And I would be surprised if that was not, well, that definitely is a country that's connected to many blue nodes, which is final games. So probably it's one of the teams that has played more finals. Again, I guess it's going to be Italy. It's going to be Brazil.
It's going to be Brazil. Okay.
So that's it. So we have and then of course there's many others that are connected to only one. Like for example, we have here France or
there must be England somewhere.
Yeah.
Sad, lonely England.
Well, it's not a world champion, so that could be worse. So yeah, probably have another one here that England. There you go. So that's England. Here you are. So what other interesting things can we maybe see from this view? The obvious thing that we would expect is to have for every World Cup, which are the dark, the green, nodes, to have a final, right? So there's a blue node for each green node, but we see that there's something a bit unusual somewhere.
Yeah, it's kind of down on the bottom.
So left, is it this one here, right? Oops, let me select just this node. So if we pick this World Cup, we see that it's connected to a number of blue nodes. So how can a World Cup have
it's got like six finals.
Exactly. So it's, I think, which World Cup was what this is the 1950, and it was because it had a different format, right? So we did some investigation after that, and the thing, it was like a sort of a league, and whoever came up in the top of the table was the world champion. So it was a kind of an unusual World Cup in that sense.
This is a weird one. So we kept like the data quite like exactly the same as how it's represented, but it's not obvious what should count as the World Cup final for that one. Whereas in all of the other tournaments, it was very obvious because there was a round final, and it's like, okay, well, whoever won that won it. Whereas here, it's not clear
finalists,
what that should be. But what is nice about this is that we kind of we don't really know. Like we just typed some things in. We had a rough idea of what the structure was. but I didn't know that was what happened in the 1950 World Cup. I wouldn't know off the top of my head that Brazil were the biggest finalists, but you can see visually from using this tool that that's the case. Another one that I've persuaded Jesus to let me do is to find all the England hat-trick scorers. So if we start from England, we can say, hey, find England, find the squads that England have named, find the players in those squads, find the appearances they made, and find the goals that they scored in those appearances. So that gives us this nice graph here. And if you're over the weekend at England, commentators were over and over again going, oh, there's only been 3 hat-tricks ever. And you can kind of see them. So there's one where my cursor is on the right. Jesus has found another one over here. And if we look at the orange node connected to them, see, if you don't know, see how quick you can answer on the chat who those 3 people are. So
is it 3 people? Is it 2 people?
So it should be 3.
Oh, there's 3.
There should be 3. So if you click on that one, who's that?
So this one is okay. This will be.
So we've got Jeff Hurst. So that's the most. I guess that's the most famous. The famous hat-trick. We've got one down here. This is Harry Kane. So Harry Kane's in there. And then there should be one more somewhere else. I don't know if we can. Can you spot a 3 up here?
Yeah.
So this one. So actually, what you can also do is on the appearance, we can go find me who started. So it's actually Gary Lineker. So you can see here we can look at the neighbours as well. So you can see this appearance was connected to a particular match. It was Gary Lineker, and then there were 3 goals. Very early goals here, 9, 14, and 34. So that's like the sort of things that this sort of exploration you can do. You can also do some shortest path searches. So I guess let's just clear this, and maybe we can look up a couple of players.
Right. Okay. Yeah.
So we'll go with the 2 players who are competing with each other to be the GOAT. So if we start, let's start. Should we start with Messi?
But,
so we just so actually one nice thing.
What are the search strings?
Yes, you can just type Lionel Messi, and we can find.
Right. So we
find him. So so if we just look him up on his own.
You mean like just
we'll just do Messi.
Messi here.
And then we'll do Cristiano Ronaldo as well.
Cristiano Ronaldo.
So we've got both of them. So we've got 2 nodes on their own. And what we can do now is we can actually we can go and select both of them. And you get like a nice little pop-up menu here. Say, okay, what's the shortest path between them?
Well, and the shortest path is apparently the fact that they both played in the 2014 World Cup. So it's not really all that close, apart from that they were in the same group. Closeness, yeah. Good. And what else can we ask? So
you can then, if we wanted to, we could add another node in, and we could find the path between them as well. But another nice thing we can do is the search phrases. So this is like if there's something a little bit complex that you want to do, and you kind of want to share it with some people who might go and use this search term. So if we go over to the search phrase bar, we can see. So it was,
for example, define constituency players. We don't want to have a look at. Right. So what you do is, as Mark was saying, so you have a cipher expression that runs something a bit more complex, and like, for example, the connection between 2 given players. You can sort of can that query and define a number of parameters. And here is, for example, the name of the players. And that will be exposed to the users in Bloom with what we call a search phrase. So what you have to do is type the search phrase, and it will prompt you for the 2 parameters, for the 2 players that you want to find the connections. And
I think we did.
Yeah, I think we created another one. But it didn't. Yeah.
So we did one here, which was finding all the shortest paths between the players, and then we decided that was a bit too generic, and so we customized it a little bit to say they've actually got to
exactly, because that would include the kind of relationships that we found between Messi and Cristiano Ronaldo, that they were just had in common the fact that they were in the same World Cup. But if we want to be more specific and say we want them to have played in the same game, played against each other, what we want to do is restrict the type of relationships that we want to traverse, right? So that's what this cipher does. So effectively, this is co-appearances of the same of these 2 players in the same game.
So I think we got it. I just forgot to rename the description.
We just put call it a description just to make it. Okay, let's Save these.
I think oh, there we go.
That's it.
So if we go
And if
out
we
to
go
here now,
here,
we can actually type that in, and let's.
it was,
Should we try and find the matches of Toni Kroos and Messi maybe?
so we find co-appearances, and
So yeah,
we
if you
said
just type, if we just type in Toni, it actually like start I. Come on, man, he plays for your team.
Kroos.
Is it I? I'm Toni.
Oh,
We've gone for the British Toni. So like so you can see it gives us the autocomplete of Toni Kroos down here in position 3, and then it will actually go, okay, now I'll give you another place, and maybe we put Messi in there.
And Lionel Messi, there we go.
And
what we find is now just the games where they played against each other. So we see for each one of them, we have their appearances, which are the red nodes, connected to one of them is the final last World Cup.
What was the other one then?
And the other one is the quarterfinal. We can double click and find out that it was
2010.
There you go, quarterfinal in 2010. Cool, that's
so I think this is the type of stuff thing that you can do with Bloom, and so hopefully we've shown you some different ways. Like we've shown you 3 different ways that you can query the data, and all of them have like almost like a particular way of searching that it works really well for. There are some things in Bloom where you're like, I don't really know what I'm looking for, and it can help you work that out. And then once you know, hey, this is actually the pattern, and here it's like a football pattern, but maybe on a different data set, it's like, hey, go and find me all the fraud patterns so I can explore around those. Maybe you make that as a search phrase. GraphQL is really nice for navigating down hierarchy. So it's really helpful for if I wanted to build a World Cup application and I wanted to pull in data from all these different parts of the graph. It's very handy for doing that. But if you want to do ad hoc querying, that's where Cypher works really well. So if I was just like, I want to find this thing, and it doesn't really follow any structure at all. It's just like follow this relationship, then follow this one, then follow this one. That's where Cypher fits in really nicely. And as Jesus just showed, and as we showed before, you can actually take that powerful like flexibility and ad hoc querying nature of Cypher and expose it into these other tools. So you can almost consider Cypher is like probably the most powerful and the most flexible of these tools, but you can still use its power in those other tools as well. So we're just going to well, I guess we're pretty much close to the end. So we're just going to wrap up and say thank you to all of you for listening. If you enjoyed the talk, don't forget to hit the like button on YouTube so other people can find it as well. And if you've got any final questions or any things that you're curious about before we wrap up, please let us know. Otherwise, we're going to leave that database there for the duration of the World Cup at least, so you can play around with that. And yeah, if you have any,
it will be updated.
And right? It will be updated. So I don't know whether there's been any goals while we've been playing, but you can certainly give it a try and let us know. And yeah, of course, if you Will is in the chat. So if you play with any of these tools and you have any questions, you can feel free to send us an email to the developer relations team. So I'll put that link in there. So if you go devrel@neo4j.com, we'll be happy to help you out with anything that you do. So I'm not seeing any questions, so I guess we'll call it a day. So thanks to Jesus for coming and being a good sport while we looked at the 2010 World Cup. And thank you everybody for taking an hour out for your day. Now we've all got to go and watch England-Belgium playing to try and come second.
Don't say that.
Yeah. Thanks everyone. Bye-bye.
Bye.